Hello, everyone. Welcome to IGTV. Up next is William H. Murray delivering the InfraGard editorial on near field communication. Good morning, Ed. Good morning, Bill.
Good morning, Joe. Today I'd like to talk to you about a new technology and give you some idea about how we look at new technologies, how we analyze their security implications. There's a new communication standard on the horizon. It's called Near Field Communication, NFC. It is ISO 18000-3. You might want to spend a few minutes with the Wikipedia article on it. It has all kinds of wonderful applications. It has a number of security applications, and of course it has security implications and limitations. NFC is intended for use on mobile computers, such as smartphones or PDAs, things that the user will be likely to carry, like keys or a wallet. That is, that they will carry them like those things most of the time. More than a dozen implementations, mostly smartphones, have been shipped or announced by manufacturers including Bank, Google, LG, Motorola, Nokia, Samsung, and others. Applications await sufficient numbers, but payment application trials are planned for both San Francisco and New York City. Proposed applications include mobile payment, smart card emulation, including EMV, transportation and theater ticketing, electronic keys, identity documents, cryptographic key management, and dozens of others. Of course, while not requiring NFC, these same devices can be used to implement both token-based and out-of-band strong authentication. One application of NFC is as a reader of passive RFID tags and passive emulation of such tags. As you are probably aware, there is significant opposition to any use of RFID from those who fear that the value likely from such applications will not justify the leakage or other unintended consequences that may result. This opposition is likely to include NFC. For example, one application called eClone is a program for a Nokia NFC phone to read the RFID information on an e-passport. That the ability to read this information might marginally reduce the cost of forging an e-passport is sufficient reason for some to resist the use of the technology altogether. This in spite of the fact that an e-passport is much more difficult to forge than an ordinary one. The name derives from the inductive effect of the near field, that is within 2 wavelengths of an antenna. The reliance of the technology on this effect limits its effective range, but the far field effect of the same antenna might leak information beyond the effective range, perhaps at a distance of a few meters. Because unlike Bluetooth, NFC does not provide encryption, for some applications, encryption such as SSL or MIME might have to be implemented at a higher level, the application layer. NFC is also low power, 15 milliamps, and consequently relatively low speed, 420K bits per second. However, it has one great advantage over competing technologies, that is connection setup time. While Bluetooth may take seconds to establish a peer-to-peer connection, even after pairing, NFC takes less than 1/10 of a second. Indeed, one proposed application of NFC is for pairing Bluetooth. While the operational range of NFC is intended to be about 4 centimeters, eavesdropping might be possible at a range of meters. As with any technology that is vulnerable to eavesdropping and replay, NFC is weak, that is, one-factor authentication. Most of the security applications will require strong authentication, at least 2 factors plus resistance to replay. To the extent that NFC is implemented on handheld computers, a wide variety of authentication schemes will be open to application designers. NFC signals via amplitude modulation. Its ability to resist the modification of a bit is a function of the strength of the modulation and the coding used. However, some NFC applications may have to provide encryption to resist data modification attacks. Because NFC is low power, electronic jamming will be relatively easy. Of course, the same is true of Bluetooth. The experience with Bluetooth suggests that this is a vulnerability without a problem. However, NFC may not be suitable for applications where ultra-high availability is a requirement. NFC devices are vulnerable to loss, along with any credentials, privileges, and capabilities associated with them. Applications should resist the use of lost devices by implementing lock words for use of the device, remote disabling and erasure, and other security mechanisms. Abandoned NFC connections might be vulnerable to exploitation until and unless they time out. Therefore, devices and applications should be designed to time out in the minimum time adequate for the application. Now, those of you that are followers of IGTV or my blog know that I am a longtime critic of the use of magstripe and pins for our point-of-sale payment system. Outside the US, EMV cards are being used to improve the system. That is, smart cards, or what the Europeans call chip and pin, complying with a standard proposed by Eurocard, MasterCard, and Visa. However, progress is limited by the implementations that are backward compatible with magstripe and pin. That is, even in Europe, where chip and pin is used, backward compatibility to magstripe is still a problem. And perhaps this is they insist upon having this backwards compatibility to be able to process the cards carried by American travelers in order to get our money. Although there are EMV cards and merchants prepared to accept them in the US, there are no plans to deploy them widely, much less pervasively or exclusively. This is in part because of the cost of the cards and readers, and in part because they do not solve the card not present problem. That is, they do not solve the problem of mail orders, and not only can NFC of mail order and internet purchases and home banking and all of those kinds of applications. Not only can NFC devices both emulate and read EMV cards, these smart devices can address the card not present problem. Moreover, handheld devices can emulate multiple cards and accounts, functioning as e-wallets and reducing the number of credentials and tokens that a consumer must carry. We might get to the promised land of a single device. Like many such technologies, near-field communication is inherently neither secure nor insecure. It is proposed in good faith and with high hopes for legitimate applications. However, I have now lived long enough to expect poor implementations, inappropriate uses, and unintended consequences for any novel technology. I'm not without sympathy for those who fear technology in general and RFID in particular. I will be surprised if NFC is not chosen for some applications for which it will not be secure, and for others, as with magstripe and pin, it will survive long after the use has stressed it to the breaking point. The securability and reliability of NFC applications will depend in large part on the devices on which they are implemented. That is, in the ability of those devices and their operating systems to resist application-to-application data leakage and interference. These mobile devices are already being used for financial transactions over the internet and for financial applications using graphical readers for barcodes or QR codes. However, it's clear that these systems will vary greatly in their ability to protect their applications and will rely to some degree upon their users and vendors to keep them both sanitary and current. We must be prepared for the technology to be blamed for any compromise with which it is even remotely associated. Still, I'm hopeful that NFC will find many security applications and securable implementations. I particularly hope that it will find application in the payment system, for example, by emulating EMV. By emulating EMV, perhaps it will encourage its further adoption in cards. We must design and choose carefully and apply and use conservatively. We should err on the safe side. We have to prepare diligently and advance cautiously. It will be difficult and risky, and it will challenge our knowledge, skills, and abilities. That is why we are called professionals and are paid the big bucks. See you next week.
Thank you once again. Thank you once again, Bill. We certainly appreciate it, and we look forward to hearing you the following week. Goodbye now.
Bye.